Hi and welcome. Let's talk about SSH Agent Hijacking. Typical scenario is you have a production environment, right? And then the developer, in this case Bobby, kind of wants to access a certain machine in production. And the very common use case is there's like a jump box, like a special server. And what Bobby will do, right? They have SSH set up. He will SSH to that server. And from that server, then the question is, how do I get to this production instance? So there's now network connectivity only between these machines so that the production environment is otherwise isolated. So how do I get access to that production machine now? Like one way would be, right, you just copy that SSH key onto that server, onto that jump box server, and then you can access the production environment, right? This would work, or this does work, and it's actually often done, but this is bad. The reason it's bad because you don't want to have the private key lying around on random machines that somebody could just grab. Another way to tackle this problem is by using SSH Agent. So we have a server and we have Bobby, and Bobby launches the SSH Agent on his machine. And he loads the key, the SSH private key, into the agent. The key is now inside the agent, but only in memory. It is not stored on the disk. And the way to communicate with the agent is via this socket, right? There is a random socket the agent creates when it starts up, and it is stored in the SSH auth sock environment variable where the location of the agent actually is. Now, Bobby can perform SSH agent forwarding. So using that command, SSH with -a, he logs into the server and everything is good. The way this typically looks in a production environment, so you have Bobby who starts up SSH agent, puts the key into the agent so it's stored securely on the machine, and then Bobby performs SSH-a, which forwards the key to the next host. On this jump host, another agent will be launched, right, that then provides access to Bobby's key on Bobby's machine, and then Bobby can perform an SSH command to pivot into production on any of the hosts that he wants, for instance, requires to debug. And the way he does that, right, when he performs the SSH command, it will look up the SSH authentication socket. There's an agent running, and that will give access to the agent that runs on Bobby's laptop. And then Bobby is granted access into production. And this might actually happen, right? There might be many concurrent users using a jump box like this, and they all perform the same pattern, right? They forward the SSH agent, they have a key in the agent, they forward that to the jump host, and then whenever the SSH on that machine, the key from this machine actually will be leveraged, and the key never really leaves the secure location. But what if Mallory is on that same jump host or compromises that same jump host? What Mallory can do is just perform the following action: set the SSH authentication socket to, let's say, Bobby's agent, and then perform the SSH command as Bobby. What this will do is will leverage and hijack Bobby's agent and then use that agent to move on to attempt to authenticate to, let's say, this first production server we see here. And since Bobby's agent's key is valid, that will work. And the attacker can use this to compromise any of the other machines in the production environment. Let's take a look at a practical example of SSH agent hijacking. Here you can see we have a jump box and the user hacker is logged in. And at the same time, this host is used by multiple other people. The attacker would run, for instance, ps3 and take a look of all the other SSH sessions that are running currently on this machine. And we can see here, right, there's Alice is being logged in. This is our session, the hacker. Alice is another session. There's also Bobby. What an attacker is looking for, what you're looking for is the SSH daemon starting, for instance, here, a bash session, a bash shell. So we take the process ID, the bash session. We then query the process file system, querying the environment. And then there's this little trick to kind of format the output a little bit better. And we grab for the SSH auth socket environment variable. This is basically the only thing we need now to set this environment variable when we create our new SSH session. And then we can just leverage Alice's account and Alice's SSH agent connection, which would basically point back to her machine, which stores the key. And we then leverage this to pivot as Alice to another machine. So take a look. We are now hacker at Jumpbox. We perform this SSH command to Commodore as the user Alice. And look what happens. Here we go. We are Alice and we are on the host Commodore. That is SSH Agent Hijacking. Sometimes you might not always find the environment variable, but if you're certain that the user loaded keys into the agent and that the user started an SSH agent, you just can't see the socket connection of this environment variable pointing to the socket. The reason for this is that the environment from the process file system is only captured in the very beginning when the process launches. So if a user adds a variable later on, it might not be visible. And there's a little trick. You just can dump the process memory and then search for the environment variable in the process memory. There's a way in Linux. There's actually a tool. Let's look at PS3 again. Find Alice's process ID here, and you can do gcore and just give it this process, and it creates a memory dump. So now you can see here. I think it's just called gcore or just core. Yeah, so you have that here, and then you just run strings on that. It's like the really kind of cheap way of doing is SSH auth socket, and that way you get the same information back, right? It's the same environment variable is stored in the process. This is usually not necessary, but I've seen it once in a while where the environment variable was actually not set, and the environment variable was set, but you couldn't see it with the process file system. Okay, I hope this was useful. You enjoyed it. And if you enjoyed this video, click the like button. So you can also subscribe to the channel. Let me know comments. And happy hacking.